Hello everyone and welcome to C# 101 and Introduction. This is week 3 with our Monday class. Welcome everyone. It is good to have you guys with us today, and hopefully you've brought yourself prepared to learn. Alright, so today we've got several different things that we're going to be talking about. Major topics though include introduction to lists, for loops, for each loops, and an introduction to switches. And then some fun homework for us to play with. Now, has anybody noticed if by any chance Gavin has managed to join us? A, B, C, D, E. I still do not see him today. So, alrighty. But anyways, we'll be talking about homework a little bit later on once Gavin does join into the class. The most important thing that we need to discuss right now is passwords. One more time. For those of you that joined us in this past Saturday's class, the Blender class, if you recall, we were a bit confused as to why the password was not showing up on the live classes system. And it wasn't a bug, it just comes down to the way that Nelson designed it. Basically, there has to be a registration link for you to see the password show up. So, again, Nelson, can you go ahead and bring a browser up into your... Thank you, sir. Jump on over to 3D Buzz, and inside of 3D Buzz, again, there's a live classes link at the top. Simply click on it, and then you can see right now, you'll see the legend over there. Well, the legend at the bottom, there you go, thank you. And you'll see how there is a P on the 12th for today, indicating that there is a password. And then, as Nelson just demonstrated a second ago, you simply click on the Intro to C# 3A, and it will basically open up, and you'll get the password. The password will be posted within 5 minutes of class launch time. So, just wanted to throw that out there. Nelson, is there anything you want to add about that?
No. Other than you can also grab the video and homework link as well, once those are made available.
I will continue to put the password for now over in the thread as well, but I just want people to start getting into a habit of coming over here, because this will make things a lot easier, because those threads do end up getting buried if nobody's posted in them in a while, and then it becomes a bit of a nightmare to find the password. So one easy place to find stuff. Okay, so this week, let me see, calendar up in front of me, looking at Wednesday. Yeah, so we need to do another open hours session. I'm thinking this week it'll be Wednesday. It'll have to be in the evening time. What do you think, Nelson? Maybe 8 p.m.? Which would be 6 o'clock?
6 here.
Yeah.
Yeah, that should be good. Yeah, that gives us time for the private classes.
Yeah, exactly. So, all right, guys, you heard it here first. There will be a open office hours this Wednesday, the 14th. So March 14. So it'll be a Wednesday at 8 p.m. Central Time. So you can figure out the time. I'd say right now we're not GMT -6, are we? Because we just had the time change and all that crazy stuff. So I have no idea. I can tell you guys right now it's 3 o'clock. Most of you guys figured out the time just fine, and you were able to get in here. So whatever time it was when this started, add 5 hours to that. We have to do all sorts of crazy maths just to figure out when we're going to meet. That's insane.
All right. There's a Gavin that just showed up too.
Okay, I'll bring him over. Good deal. All right, Nelson, if you want to go ahead, and I will get that also entered into the calendar for the open office hours for the C# class a little bit later today.
Sweet.
All right, so if you want to go ahead and pull that out of the way. Now, one of the things I want to avoid doing, like we did last week, was a really long review, something that eats up, 20 minutes. And we've only been recording for 5 minutes now, which is great. So just, if there are any questions about last week, we went over, we added floats, decimals, and booleans and doubles. Well, we talked about booleans, but we added a few more data types in. Then we talked about arrays. We talked about type conversions. Yeah, that was the main stuff. So if there are any questions, now's a good time that you guys can throw those out. Otherwise, we'll go ahead and get started with the content for this week. Hello, Gavin. Good to see you're able to join us, sir.
Hello there. Sorry, I was coding.
It's okie doke.
It was 2 hours ago, half an hour ago.
Yeah, that's generally how that works.
It's like, Nelson made me jump out of my chair. Well, Skype did.
All righty. So let's see. Same here. I'm having had input issues. Max. Okay. All right. So I'm just looking real quick. Remember, today, please, everybody make use of the questions panel for asking questions over in the webinar system. So if you have a question, otherwise, I'll give you guys about 30 more seconds to type it out. Type fast!
Well, we could just, ask people to raise their hands if they have questions and wait for them to type out. I mean, if people are typing out really long questions.
Okay, I'll put all hands down, and if you are typing out a question, raise your hand. All right, we have questions coming.
So are we going over the homework in this class, or is that the open hours?
We'll probably do it during open office hours.
Okay.
I just want to avoid... It's still a very interesting problem, especially having 2 classes a week, 2 of the same class.
Excuse me.
All right. Thursday night's class. See, I want to make sure that this is straight. Thursday night's homework is due before this class. Gavin, we were talking about that the other day, and we were saying that it's really unfair to put Thursday night's class in that position for people that don't actually have the time. Where Monday.
When is the open office hours then?
That's going to be Wednesday. The day before.
Okay, I will, because that's why I had meant to update it. That's my fault.
We could just simply tell everybody to get it in by Wednesday.
Yeah, I'm just going to update it on the thread, but I
Okay.
didn't know at the end of the last lesson.
All right, cool. So
when we were going to have that.
So there you go. By Wednesday. So don't worry about it, Ryan. Hopefully that'll answer your question. By this coming Wednesday, March the 14th. And Gavin is going to update that.
That one.
And Alexander has asked, will the open office come to see later? Or come up to see later? I will post the video. There's not been a rush to post this last one with everything that we've got going on, only because there was almost nothing that was done in it. But I'm sure questions will begin to pile up once we start getting into more advanced content. And Ryan says, okay, so I turned it in already. Can I resend it then? Were you going to turn in a different version?
Basically, I'll mark the most recent one that comes in from people.
Oh, there you go. That one that fully works. Okay, cool. So yeah, you can go ahead. You can go ahead and resend. Just resend before.
And what time are we having the office hours Wednesday?
It's going to be 8 p.m. at night. So
5 is.
So around 2 in the morning your time, 1 in the morning, something like
1
that.
in the morning with the current, I think.
Yeah. Okay, that makes sense.
But that'd be 7:59 Central Daylight Time.
Yes.
No, CST, CDT, CST.
I thought we was changing over to CDT. I don't know.
I hate time. I hate time. I hate time.
Me too.
Somebody put it in BuzzNet for me, so me looking it up.
CDT.
Thank you.
Yeah, I thought so.
Right. Save. Okay, refresh your browser and you should see a new due date.
And Ryan asked, should I leave this class? We're not going to review it today, Ryan, so you're more than welcome to stay joined in with us. And Steve is asking, is there a new version of BuzzNet that works behind the firewall? No, we've been using the same BuzzNet that Nelson put out a couple weeks back. I believe Nelson, if you want to update everyone on the web version, which will work behind firewalls just fine.
The web version is going to be ready for a public test today at some point after the class. So I'm not exactly sure how we're going to organize that, but I definitely want a large group of people to test that outside of the context of a class, just so we can hammer out some potential issues before a class is actually started.
Very cool.
So I'm not sure how that's going to be organized, but that'll happen sometime today or tomorrow.
And the nice thing about having the web-based BuzzNet is it'll work behind firewalls without any problem. All you need is a browser, and
you don't have to worry about updates and. Yeah,
it's going to be very nice.
I did have one message from someone who shall remain nameless, who I hadn't looked at their first version of their code yet, but has apparently used array.sort in order to do their homework.
I thought we were pretty clear about not doing that.
I think we were. I think you finally watched the video and went, oh, yes, the point is not to sort 4 numbers. There are ways of doing that. The point is to know how to sort 4 numbers.
Exactly.
Or 5 numbers.
And Ryan has backed us up and said, yes, we were very clear about that. Good. He said, otherwise I could have had it done in a single line. For those of you that have just registered for the class, get your homework caught up quickly and get it sent to Gavin. And let him know that you have started the class late. I mean, he'll be able to identify that. One, with those of you that I've talked to via PM and email, I've told you to tell him that I said that it was all right that you had started late. And the second thing, it'll be kind of obvious when you start rapid firing off the back emails. Now, after this week, it's going to be pretty much beyond difficult. It's going to be impossible to get a certificate.
It's going to be not happening.
Because after this week, you won't be able to make 50%. Well, actually, you still could. This is the 3rd one, 4th, 5th, 6th. Yeah, so after the next class, it'll be impossible because you couldn't attend 50% of the classes.
But basically, in terms of the due dates for the first homework, anyone who's signed up by now and I've had a few of these emails where they've messages where they've emailed Jason and have submitted their homeworks for week 1. Basically, if you've just submitted, you're going to have to catch up as quickly as possible. Week 2's homework is, as I said, it's due now on Wednesday. And we'll be into week 3's homework, at which point I really don't want to still be receiving homeworks for week 1 of this, along with anything else that I'm doing for different classes and such like. So I vote that if there is a cut-off point.
Well, I don't think we have that many people that are signing up right now, but I do know for a fact that once next week's class is missed, there's no way anyone can get a certificate anyways, because they won't be able to comply with the 50% attendance rule. But we'll talk about that afterwards. I don't see a lot of new people signing up for this particular class anyways. But with that, is there anything else homework-wise?
Not for me.
Okay. Well, let's go ahead and jump over into some new discussion today then. And Nelson, You there?
Yes.
All right, well, let's start out with lists for today.
Alrighty. Or we can update my VM.
In 4 hours from now.
All right, so I'm going to go ahead and fire up a project. And hopefully everybody is there at this point, has Visual Studio open, has a new project open. Okay, so lists. Last week we looked at arrays. So an array, you have something like int my ints equals new int 10, and then we could access those elements individually via the indexer. Now, arrays are good, and the concept of arrays are good, but there's an issue with arrays. The biggest issue with the array construct is that the size of the array must be known at the time of instantiation. So that's obviously going to limit us in a lot of different scenarios when we don't necessarily know how many items are going to be put into the array. Like imagine a better user interface for some of the programs we've been writing could simply ask us to continually type in information until we just maybe double tap the enter key, instead of having to ask us how many items we want to insert. So a list is a type, and its type looks like this. This type exists in the system.collections.generic namespace. And this particular type is a lot more interesting than the other kinds of types that we use, or we've been using, such as int, bool, string, decimal, double, and float. All of those are called basic types, or primitive types, because they are, generally speaking, the smallest unit of data that we can store in a variable in the C# programming language. A list is a lot more complex than that. It's a higher level of a type because it actually composes these different types to produce some sort of result. Now, even though this is the type of list, there is one interesting thing about this that unfortunately we're not going to be able to explain in detail until later. And you're just going to have to accept it. But list accepts something called a type parameter that we must supply inside of these angle brackets. Is that what they're supposed to be called?
Sounds great.
I don't know. Okay, angle brackets. We must supply another type into these angle brackets. So that's very important. Think of it like this. You have an int array, and this is what an int list looks like. Whenever you use a list, you must always specify that type parameter, and it must be a valid type.
And
it can't be a value.
I was going to say, just to drive the point home, do a string array, and then throw string in there, just to show also valid.
A string? Oh, you mean string in here?
Yeah.
Or
so you can also have a string array, and this is a list of strings.
A bool, a float, a decimal, but you cannot have a thing that is not valid because it's not a method invocation. It requires that you pass in a fully, or not a fully qualified necessarily, but a valid reference to a type, like that, integer or string. So that's going to be the full type. And the interesting thing about the type of this type is that this type in particular is actually pronounced list of int. List of string is actually a different type. That's going to be very important because you cannot assign a list of strings to a list of ints, and I'll show that in a second. So that's the type. That's the full type. You have the list part, which is that, followed by the type parameter, which is that. But we still haven't gone over what lists actually do or how to use them. So I'm going to go ahead and give this variable a name, just like we do normally. So remember, a type followed by an identifier. So we now have a variable. And then I'm going to initialize it. And a list of anything can only be initialized to an instantiated list of that type. There's no list literal or something like that. So we have to initialize it with equals new, the instantiation operator, list of int. So now we have a fully instantiated variable called myList, and myList is of type list of int. It's named myList, and it's currently set to the result of creating a new list of int in memory. Now, remember how I said that this is the full type of this type. This is it's called the closed type. This is not valid ever. Almost ever. There's one situation where this syntax is valid, but we're not worrying about that. This syntax isn't valid for
as far as you guys are concerned. That is not valid right now.
Yep. You must pass in a type parameter, not an expression parameter like you normally would be able to do with methods. But however, by specifying a different type parameter, we actually changed the type of this type. So this is now a list of string. Whereas this is a list of int, and this is a list of string. And you cannot assign a list of string to a list of int. Just as you can't assign a list of ints to a list of string, and so on.
Now we had a question come in that's asking, what are the parentheses for at the end?
That's a good question. The instantiation operator, new, expects us to pass in a type. So the syntax of instantiation, with the exception of arrays, which you see right here, which is so far the only time you've seen an instantiation, is right here in this array. But with other kinds of types, it follows this pattern, and the pattern is the new keyword followed by the type you want to instantiate, followed by what looks like a method invocation, and in fact it is. If we were to inspect what this method wants, you'll see that here's a method that takes in no parameters. Here's a method that takes in an integer for the initial capacity of the list. And here's a parameter that we're not going to care about just yet. But my point is that when you instantiate an object, or when you instantiate a type into an object, you start with the new keyword, followed by the type you want to instantiate, followed by a method invocation. And the method invocation is actually a special method called a constructor, which we're going to go over in week 6. But when you see those parentheses, whenever you see the parentheses, you should really think method invocation. And that's exactly what's happening here. When this list is created, it gets an opportunity to do its own little housekeeping during its instantiation. And that's what this method right here provides. But I just wanted to remove that mystery from anybody. You can just think of it like a method invocation.
And do you have your questions panel out, Nelson?
Yeah, I'm trying to read it through it. I can't pay attention to the chat, by the way, so if people are asking questions in the chat, really, you should put it in the questions panel.
Correct.
Okay, so can you use something like TryParse to change a list string into a list of int? No. Well, yes, but you would have to loop. Lists are similar to arrays. Yeah, I'm going to get into what a list actually is. All of what I've said so far is applicable to any sort of object that we might be wanting to instantiate. I just wanted to go over this syntax and this concept of being able to change the actual type of an object with a type parameter. Not that we're going to be talking much about this even in this course or how to make these kinds of classes, but a lot of people get tripped up with this.
One question that came in was, what do you mean by housekeeping?
The list object might want to do, well, it can do anything it wants to. Basically, if it needs to perform any sort of initialization immediately after it's created, then that goes into what is called its constructor. And we're invoking the constructor right here. It actually is not valid C# to not invoke the constructor. You'll get an error. As you see, a new expression requires parentheses, angle brackets, or curlies after type. So I just wanted to drive home that this is a method. that's being invoked. So that's why you cannot leave these off. And a lot of people will end up leaving these off. So please just keep in mind that you have to, because every time you instantiate an object, with the exception of arrays, you're going to have to invoke its constructor somehow.
And NATO asked, is there anything you can't make a list of? I think is what he meant to ask.
For example, instantiated classes. No,
I think what he's meaning is not instantiated classes. I mean, with your own custom classes, you can, of course, create a list. You have to supply in those angle brackets the type. So that type would be your custom class. And then you could store a list of the instantiated instances of that class.
Yeah, but there are certain types that you can't have a list of. The rule of thumb is anything you can have, any type that you can make a variable out of, you can use to make a list out of.
Yes, on line 12, he's declaring an array that contains 10 items.
So sending things into the constructor is what you mean by housekeeping? No, what I mean by housekeeping is any responsibilities that the list needs to perform in order to be able to fulfill its duties. And those responsibilities are irrelevant because we don't have to worry about them. List does.
Yeah, it's just hidden from us. It's in the black box. Okay, I think that's
okay.
Got
So
all the questions.
Now let's talk about what a list object actually is and lets us do. Well, a list object gives us a bunch of these fancy methods. I'm going to go ahead and nuke the using system.link on line 3. So if you want to do that as well, that'll give you a nice, more straightforward list of operations. The ones that we're particularly interested are, of course, going to be things like add and remove and insert. And so what do these operations let us do? Well, list is a collection type. As you see, the namespace that list is in is called system.collections.generic. List is a collection type, which means in .NET, a collection type is going to be a type that is capable of storing data in it, like an array. The list collection type is the simplest collection type out of all the ones provided by the .NET framework, but its functionality is basically it behaves the exact same way as an array, but it lets you add as many items as you need to. So for example, I can go ahead and say my list.add 10, 20, 30, 40. So it's a flexible array. You can think of it that way. The way list actually works behind the scenes is it uses an array, but whenever it detects that you have filled up the array, it's going to go ahead and copy that array to a larger array, delete the old one, and then add your new item to the end of the newer one. So basically think of this like a way to not have to keep on reinstantiating your arrays, copying values over and all that stuff. List handles it all for you, which is why the list collection type is the simplest one of them all, even as far as how it's implemented behind the scenes. But in this case, what we have here is, and I do want to point this out, in a lot of languages, particularly a lot of dynamic languages, like PHP, Ruby, JavaScript, and all that stuff, they all have something called an array. Now, the funny thing is that those languages' arrays, if you're familiar with these languages, behave like C#'s lists. They don't behave like C#'s arrays. One of the really confusing things from people coming from PHP or JavaScript is you use an array in C#, but you can't add more items than what it can hold. You can with lists. So lists are closer to what you'd be used to working with if you worked with dynamic languages. So it prevents errors in calculating the size of array. Yeah, it does prevent errors for the most part. It'll still yell at you under circumstances where you try to access things that don't exist yet, but it will make it so that if you repeatedly add items to the list, you'll never run into a situation where you get an out-of-bounds exception. I come from Java where list is an abstract class. You cannot instantiate a raw list. Does C# have list implementations, e.g. something like ArrayList? It does have something called ArrayList, but that's another instantiatable class that has no relation to list. I'm not entirely sure what the responsibilities of the list class is in Java, so I can't answer that question. Why would you ever use an array instead of a list? Good question. I wouldn't. Very, 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 very few instances I'll use an array instead of a list. Very few. The reason we introduced arrays first was, first of all, you need to know about them. And second of all, it provides a great segue into an object that is slightly more complex than an array, but gives you a lot more functionality. Elevating says, sounds sort of like a vector. He's referring to the std vector in C++, and it is exactly like a vector. Even as far as implementation behind the scenes. Yeah, just better named, exactly. I hate the name vector. All right, so is everybody good so far? I do want to point out, though, before I ask for questions, is that yes, you can access, you can set and get items out of a list using the indexer syntax. And one other thing, though, and this is going to become very important, my list does not have a length property like arrays do. Very, very important. Instead, it has a count property. So when working with lists, you will do .count instead of .list or .length. But with that knowledge that you have all the functionality that arrays provide. So as you see, my list contains 4. You have all the functionality that arrays provide in the way of initializers, in the way of indexers for getting and setting properties. And you have a way to get the count of a list. You can see that it pretty much has all the functionality of arrays. It's just going to be a lot nicer to work with and going to provide you a lot of functionality. Lists are zero-based. Everything in C# is zero-based. When it involves an index, it's going to be zero-based. Alrighty, well, I'm going to go ahead and put hands down. And if you have a question, go ahead and put up your hands. Actually, it would probably be a good time just for people to type this out. I'm going to delete the array example above. And for everybody to type out this syntax right here, particularly this. Because this is so different than any other variable that we have created, you're going to have to become very familiar with this. And unfortunately, list is going to require that you at least understand the concept of putting in these angle brackets and supplying a type and nothing else. Although these angle brackets do represent a fairly advanced feature in the C# language that we'll be covering in a different course. Wait, count is the amount of items in your list? Yes. So if I were to do my list contains my list.count and then my list.add 20, count will now be 5. I removed system.link because including it in the using declarations above will clutter up the methods that we have available, and we are not going to be covering link. There is no length property on lists. If you look in its member list, there is none. The only way to get the number is through count. Yeah, done. In C++, they're called templates. C# they're called generics, which are much more powerful than C++'s templates or Java's generics. Ugh. Those things drive me insane.
So what's next?
I'm waiting for people to ask questions, and type it out. But apparently we have a bunch of really fast typers and people who don't have any problems with lists. Yes, there's a way to remove an item. It's simply going to be my list, or I should probably do it after I've added a few items.
Yes.
But my list.remove. And then there's a what I do is it removes the first occurrence of a specific object. So if I were to pass in 10, it'll remove the first item. Alternatively, you can do mylist.remove at, and remove an item at a specific index. So in this case, this code will remove 20 because this code will remove 10 from the first index, 20 will become the first index, and then since we remove at 0, 20 will be deleted as well. So finally, at the end of these two remove statements, we'll have a list with 2 items in it, a 30 and a 40.
Is that that's a key point that actually I'm not sure of on arrays, which is when you delete the first index of a list, it bumps everything up the list. Does that happen with an array as well, or do you end up with an empty space?
Well, there's no way to remove an item from an array.
That'd be why I've never tried it then. that was good. But yeah, it is a key point to notice. Your indices will change, and in fact, you get errors at certain points. I'm thinking for loops, but that's for when we get to them.
All right. Does remove at cause the memory to be reallocated? Yes, because well, yes and no. Just in the sense that remove at will, if it's a reference type, remove at will remove the reference, and if there are no other references to the object, the garbage collector will eventually clear up that memory for you.
That's correct.
Remove at seems much less confusing. Would you only use remove when there's a specific value you don't need? Yes. Now, when we're using primitive types, remove at makes a whole lot less sense. But imagine if we had like a person type, our own custom person type, and we wanted to delete a specific person. At that point, we know that every item in the list is going to be unique. Now, when using primitive types, that's not necessarily the case because you could have mylist.add10, 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 and so on and so on. It doesn't make sense for value objects as much as it does for more complex types. Can you have a list of lists? Yes. Remember, list allows you to pass in any valid type into the generic parameter. So we could have a list of lists of ints, but we cannot have a list of lists like that because remember, this is not a valid type. It is a type, but it's not a type that we can make a variable out of. However, if we were to say list of ints, then we could do that if we wanted to. Can you get an index by inquiring an item on the list? Yeah, there's going to be a mylist.index of method that'll return the index of an item. There's also an index of, in last index of method that does the same thing but searching backwards. So removes an item with the value specify, yes. So remove 10 will remove this 10 item.
Does it not just remove the first item with the value you specify, not any item with the value you specify?
Yeah, exactly. Good point. It will remove the first occurrence of the specific object.
And then also, in case you missed this one, Nelson, if you're able to go back over the remove at on how it works.
Yeah, the remove at method is going to remove the element at the specified index. So the index is the same numbering system that you use with the indexing syntax. So that we're already used to this with arrays, where you do the square brackets followed by a number, and then you provide an index. In the case of remove at, you provide an index, but instead of accessing or setting that number, it's going to go ahead and delete that item out of the list entirely. But if I had duplicate items with the same values, it would not touch those. He's referring to the mylist.remove method, and the answer is no, it would not. Basically, now what you could do is, remember that I haven't covered this yet, but remove returns a Boolean. And the Boolean that remove returns is going to be true if an item was removed and false if an item was not removed. So if we wanted to remove every single 10 from our list, we could simply do while mylist.remove 10 and then just do an empty while loop. So this syntax will actually remove every occurrence of 10 from the list. How do you keep track of the index address of an item with all this adding and removing causes them to move? Well, that's your responsibility, really. Remember that there is an index of method to finding an index of a particular value. But other than that, it's up to you. To be honest, in the case of lists, the order is generally not something that's particularly important, with the well, it is important, but it's not something that I'll ever make my code depend on having things in a particular order. I might sort a list for presentation to a user interface, but I'll never write code that would fail if a particular item was not at a particular index, just because you're right. Items get removed and added all the time, and it's very possible that keeping track of which items have which index will become confusing. So is everybody good-ish? So when it returns true, it stops deleting items without the while loop. I'm not sure I understand.
I think they're two separate sentences. Without the while loop, it just would be removing the first one it comes to.
Yep. This will remove the first 10. This will remove every 10. Right. Well, I'm assuming that everybody is good at this point. So, yeah.
So you want to make some, perhaps some dynamic examples?
Yeah, I can go ahead and let's go ahead and make a list of a string called productNames. Should be familiar.
And have everybody go ahead and put their hands up, and not to put them down until you get done typing this out. They can follow along with you. And then once you're done and they're done, then they can put hands down. Look at you guys go. Awesome. Hands up. Hands up. Give me all your money. All right, let's go.
So then I'm going to enter a while loop. Actually, I'm going to declare a Boolean exit variable. And so that's a false. And then I'm going to say while not exit, console.writeLine, enter product name, enter, or I don't know, press enter to stop. So then I'll go ahead and say string name equals console.readLine. And I'm going to say if name equals empty string, then we're going to, actually I'm going to reverse that. If name is not empty, then productNames.add name. Otherwise, I'm going to say exit equals true. Equals throw? No, true. Okay, so now that we have all the product names, I can go ahead and do another, I can go ahead and say console.writeLine product inventory. And then I can write an int index variable, and I can say while index is smaller than product names dot length, or sorry, dot count. Then go ahead and say console.writeLine plus index plus 1 plus product names at index. And then finally, for now, we can just leave it like this. So go ahead and put your hands down when you have this typed out.
Game novice, that's what the hands are for. That's why we've got everyone to put their hands up. When you're done typing, put your hand back down again. And another reminder to people, we have said this before, but don't type the password into BuzzNet, please.
Thanks, Segfault. For all those of you who have already completed you'll see why I have such a hard problem with that later in this session, because we're going to be covering. I don't use while loops actually very often, not for iterating over items.
Not for this.
Yeah, and so you'll see why I continuously miss the index ++ because I never had the need to do it. So who asked that question about Java? Do you remember? Steen Rasmussen. There is something like that in C#. It's called IList. In C#, every interface is prefixed with I. So IList is the abstract version of the list interface in Java. And list is a particular implementation of IList, although it's not the only one. So hopefully that clears it up. I just brought up the list docs over on my other machine. I just wanted to make sure that that made sense. Is an if statement the only way to limit the index of a list? I'm not entirely sure what you mean. What are the keystrokes to highlight multiple lines of code and comment? It's going to be Control-K, Control-C. Will I go through the code after? Yes. Yep, that's basically the difference between this and all the other examples we've seen, is that this code will allow us to enter an unlimited, well, not unlimited, up to 2 gigs worth in this case, amount of product names, and then we decide when to quit. We don't have to tell the computer how many items we want beforehand, because we can instantiate lists without giving it a predefined amount of storage space, which is not possible to do with arrays.
Holds my iPhone. I wanted to use that. And I have one more arm too. Awesome. Super freaking cool.
ARM?
Yeah, it's cool, man.
I don't understand these words.
You're not supposed to.
Okay. I got my iPad dock and my iPad HDMI adapter today.
Oh, so I forgot that. Yeah, me too.
I get to sit and stare at them until Friday. Thank you, Apple.
All right, we still have just a few people left. We're close. I'll have to send you a picture of what I was talking about, Nelson.
Alrighty. Actually, did that... Yeah, people are just about clearing up.
We're almost done.
TJ's got a...
Oh, no. The empty string is literally the result you would get from console.readline if you were to hit enter without specifying a product. Like if you want to only have so many items entered and maybe add more spots later, if the index reaches a certain number, return out item slots in list. Yeah, you could, for example, inside of this while loop, you could say if you could add a int index to it and increment the index on every iteration, and then you can say if the index is greater or equal to the amount of products I'm willing for you to add to the system, then set exit to be true and don't allow any more products to be added. Yes, I'm going to be going through what this code does very shortly. A hand just came up. Console readline allows for inputting. Yes. Console.readline is a method that will return whatever the user types into the console window after they hit the enter key.
And for those of you that are entering in to the class late, this is really important just so that we continue to let people into the classes late. Make sure you go back and you watch the other classes that you've missed. As long as everybody is able to do that, then we'll continue letting people come into classes late.
All right, so we should be good now. So let's go ahead and talk about what this code does. The first thing we do is we instantiate a list of strings, and we assign it to our product names variable. So the idea is that we now have a list of, or potentially as many product names as we want, product names being strings, obviously. That's the best data type for that sort of information. So we have this list variable instantiated and ready for use. Next thing we do is we declare another variable called exit, and we assign it to false. And then we enter a while loop. And this while loop says, while exit is false, continue to loop through. So while exit is false, continue to loop. Once exit becomes true, then exit the loop. Now, inside the loop, inside this block of code, the first thing we do is we ask the user to enter a product name or to press enter to stop entering product names. And I understand that's probably not the clearest use of the English language to present to the user, but yeah. So then following the prompt, we take the result of console.readline, which will read or which will return whatever the user entered after they hit enter. It'll take whatever they entered and store it into the name variable. Now, immediately after name is stored, we have two possible branches of execution. If the user did not enter an empty string, per our user interface, they enter an empty string in order to they don't enter an empty string. Console.readline returns an empty string if they enter nothing. And in this user interface, if they do not enter an empty string, then we are going to add an item or add the product name that they entered to our product names list variable and continue looping. Because remember, once we enter this if block, this else block will be ignored. So we're not going to set exit to true. Exit will continue to be false. Because exit will continue to be false, this expression will still be true, and we'll loop again and again and again and again. Now, in a case where name equals empty string, so in a case where the user just hit enter without entering anything into console.readline, we enter this else block. And once we enter the else block, all we do here is we assign the value true to our exit variable. What that's going to do is it's going to make this expression right here return false. And remember, if the expression inside of the while loop is false, the while loop will no longer continue to iterate, and execution will resume immediately after the while block, so immediately after line 27. So is everybody more or less good with the looping and the list of strings? All right, awesome. The next thing we do is something that, well, I can't say this because there's so many new people in this class, but something that we've been doing quite a bit with arrays, where the first thing we do is we're just going to print out, product inventory, tell the user what we're actually going to print out. Oh, we did have a question. If it isn't empty, it'll go on forever, right? Yes. With this particular piece of code, there is no condition in which exit is set to true other than the user entering empty string. So in this case, first we print out something, then we declare a variable called index and assign it to the value of 0. Then we enter the while loop with the condition being index is smaller than productNames.count. Now remember, because there's no way for us to predefine how many objects might be inside of the product names list, we have to query the product names object to find out how many items it ended up being stored with, because that could be 0 or it could be 10,000. So we simply say index is smaller than productNames.count as the expression for our while loop, and then we enter in the while block while this expression continues to remain true. And all this block does is it writes out the index, but the one indexed version of this index. That's why we add 1 to it. So the first item is 1, the second item is 2, and so on, which is a lot nicer for user interface stuff as far as presentation. Then we follow that by the actual product name. And the way we get the product name is we access the list through the index variable, or through the index and using the index variable to the index of the list of strings. But just like we did before with our array indices, we're just going to pass in a variable in here so that every iteration of the loop, we're going to be accessing the next item, and the next item, and the next item, and so on. The reason that's true is because immediately following the output, we increment our index another one. So once index becomes equal or greater to productNames.count, the while loop will terminate, continue execution on line 37, which will pause the program until the user enters a key. Can we use .count to compare our list size to a finite number? Yes. In fact, I can go ahead and show, add a little bit more to this code, and it would be great if everybody followed along with this. I'm going to go ahead and say, after the while loop, I'm going to say if productNames.count equals 0, I'm going to say console.writeLine no products or something. No products found. So make sure to go ahead and write that out. It's pretty straightforward. Is there a way to declare an empty string other than just, I'm not sure what you mean. There is this empty string constant right here. Well, it's not a well, it kind of is. And there's also a constant version of that called string.empty. Both do the same thing. Neither will provide any performance benefit over the other. I just think this is clear, in my opinion.
So Nelson, we're coming up on the 1 hour mark here in just a few seconds. So do we want to go ahead and put everybody on a 10-minute break?
Yeah, that sounds good.
If there are any questions during the break, please make sure to add them into the questions panel so that we can see them when we get back. Otherwise, we'll see you guys back in about 10 minutes. Feel free to stretch your legs, grab some coffee, or whatever it is you may need to do. So we'll see you then. Thanks a lot, everyone. And I'm going to pause the recording, too. We're resuming.
And Segfault, that's not...
And we're resuming. Hi, guys. Go ahead and say what you got to Segfault.
Oh, that's not a mono. That's a Microsoft-supported CLR, which is very cool. Alrighty, so we have a program here. If I were to run this program, I would get a nice little UI. So I can say stuff and things and whoa and hey, and then I could just hit enter, and I get a product inventory of stuff and things and whoa and hey.
That almost magically went together.
So it's definitely a step up from the previous attempts that we did at writing programs like this, where we get to decide at runtime when we want to stop entering data, because lists are so much more flexible than arrays are. So it's definitely a cool thing. Now, I want to reiterate 2 points, and I want to bring up something that some people may or may not be familiar with, but it will help you read other people's code and maybe provide some context if you are familiar with what I'm about to say after I get through the first 2 things. And the first 2 things are going to be this. This syntax. We're not going to go over why this works or how it works or how to make our own stuff do stuff like this, but you have to be aware that list is a valid type. This type exists. This type is in the .NET framework, in the BCL, but you cannot make a variable out of. There's no way to make a variable out of a type that accepts type parameters when we do not specify type arguments. Second of all, this is also a type, but it is a different type than this. Those are 2 distinct types. Even though they're still lists, the type parameter that we specify actually really creates a new type given that particular thing that we passed in. Second point, again, you cannot pass expressions into this. Expressions will not work. They must be types. They must be static types. They must be actual compile time references to types. They cannot be instantiated at runtime. So I hope everybody is comfortable with that, because I think that's going to be something that people will get confused on. So just be sure that you understand that concept. Second of all, these parentheses are required. Again, this is the first time that we've seen an instantiation of an object, with the exception of arrays and strings. But for every other type that we instantiate, we must provide some parentheses at the end of the type in order to specify which constructor we are going to be using. This is a method invocation. It looks just like the other method invocations that we've been using, such as console.write. But it is a special method invocation that is only accessible when we instantiate that type. So if everybody's good on that. Somebody just asked, what about list string comma int? The answer to that question is this is invalid. The reason that this is invalid is the list type only accepts a single type parameter. There are other types that accept multiple type parameters, but we're not going to be covering them just yet.
Now, we do have an interesting thing that we can throw at our students right now, Nelson. They could update the code. We could pause the video here in a second. Everybody could put their hands up, put your hands up, and then we could let them add to this code some simple logic that would ask the user what item would they like to remove. And then it removes the item and relists everything that's in the product inventory.
Sounds good.
And then we won't wait for everyone to finish, but we will just let the bulk of the hands go down. And then, so get your hands up. Get them up. Get them up. You can do it. You know you want to do it. There you go. You too. Good. Good. Excellent. All right. So just try. Based off everything that we've learned so far, all the way up to today's class, and based off what Nelson has demonstrated earlier in regards to remove and remove at, see if you can ask the user which item they'd like to remove, allow them to remove the item, and then list it back out, the product inventory that is. If you want to get super fancy for me, put it in its own loop and allow someone to keep listing things out until they perhaps hit enter or Q or something. Anything you want to add to that, Nelson?
No. I think that's good.
So for those of you that are watching this video later in time, pause the video yourself, because I'm about to pause it here, and give it a try. And then when we unpause it, I'll have Nelson code that out and see how close you were or if you were on the right track. And welcome back, everyone. So at this point, if you've had any difficulties or if you've done it and you're curious on how Nelson would go about doing it, Nelson, show him.
Okay. Do you want me to throw in the while loop?
Yeah, because that's the way we roll.
Alrighty. Well, in this case, I would basically just say while product names dot count is greater than 0. And then I would enter this. And then I would say console.write enter product index to remove. And then I would say int product index to remove. If not, int.TryParse console.readLine out product index to remove. Console.WriteLine invalid input. Otherwise, if product index to remove is smaller than 0, or product index to remove is greater than, because it can be equal to, because remember this is 1 indexed, so actually this should be smaller than 1, is greater than product names.count console.WriteLine index does not exist. Finally, otherwise, product names.remove at product index to remove -1. So if we run this and say stuff and things, I can go ahead and say remove things and go ahead and remove 5. Index does not exist. Let's remove 1 now. No products found.
Now,
so actually that's...
While you could have completely done this without the logical operator, please go ahead and explain to them what the OR is.
Oh. This is called the binary OR operator, or logical OR operator. See, I hate that. Logical OR operator. Basically, it's going to ask is this expression true? If this expression is true, then the entire expression will be true. If this expression is false, then it'll compute this part of the OR. If this part of the OR is true, then the entire expression is true. If this part of the OR is false, then the entire expression is false. So it literally reads as product index to remove is smaller than 1, or product index to remove is greater than product names.count, then write out index does not exist.
And Adam asks if we're covering bitwise operators, not in the 101 class.
No.
But logical operators, yes, these will be introduced. As you've just now seen, the OR logical operator, which basically just means if this expression is true or this expression is true.
Yep.
And with that, go ahead and show them the and, so they'll have both or and.
Yeah, the and operator is going to be, well, I guess even though it doesn't make any sense in this case, this would be the logical and operator. And the and simply means this expression must be true and this expression must be true.
For the whole thing to be considered true.
Yep.
All right, some questions on the questions panel, Nelson?
So it moves by index, it does. Because of the way to display the index, you had to subtract 1 from the index. Yes, I display the index one-based because that's easier for humans to read and understand. But then when I actually remove the item, I have to convert it back to 0 index because that's how lists and arrays and all other collections in .NET work when talking about indexes. Also, you've added the parsing of text. Yes. This line right here, we cover this.
Yeah, I was about to say, that's already been covered. We covered that in the last class.
Yeah, you could try that.
Go ahead and read the question out.
I was trying to be clever and use either index or product name using the exists. But remember, if there's 2 products with the same name, your program will possibly not produce the output that the user would expect. Could you please go over just the general idea of the new you just put in? Are you referring to lines 45 and 46? 45 through 46.
45 through 60.
Or 60.
Basically the whole section that you just put in.
Yes, so basically what I do here is, well, actually I'm going to start on 34, because the behavior of this program is that when we enter all of our products, we want to allow the user to selectively remove items until there aren't any items left. So this while loop, the condition within the while loop is going to be productNames.count is greater than 0, which means while we still have items in our product names list, then continue to loop. When looking at this block, we start with a console.writeLine product inventory, just a little header to show the user and blah, blah, blah. We declare an index, and then we loop through all of the items in the array or in the list, which I've already gone over. Then we enter in the part that I added, where we first tell the user to enter an index we remove. Then I declare a variable called productIndex2remove, but I don't actually assign it to anything yet, because that's assigned to inside of the int.TryParse method invocation. And the int.TryParse method invocation is going to go ahead and attempt to parse whatever string I pass into it. And if it succeeds, it's going to set the value of productIndex2remove to the integer representation of whatever the user entered. It will also return true. So if this statement succeeds, the value of the statement is going to be true. If it fails, the value of the statement is going to be false. Now, the negation operator right here, the not operator, is going to go ahead and flip that. So this if statement will execute if not parse was successful. Or to say it in English, if the parse was not successful, go ahead and enter in this if statement. As far as quickly explaining the output parameter, this output parameter is mandated by the signature of the TryParse method, and its behavior is that the TryParse method will be able to set the value of our productIndex2remove variable inside of itself. As opposed to just returning a single value, this method actually returns two values if you think about it that way. It returns one value as the actual return type, which is a Boolean specifying success, but it also returns whatever the result of the successful parse was, and it is able to do that in the C# language because of the output, the way the output parameter works in this case. So if this parse was successful, we will enter the else block. Again, that is because we have negated the result of int.TryParse. Once we're inside the else block, we first compare to see if this index was valid. And the funny thing about this is we actually have to compare it in the context of a one-based indice rather than a zero-based indice. So, or index, or indices.
One index, many indices.
Okay, so we compare our one index to a collection type that uses a zero-based index. And in this case, we say if the product index to remove is less than 1. Now remember, if this was a zero-based index, we would have to say if product index to remove is less than 0. Or, so if it was smaller than the valid range of value, if it was smaller than the valid range of values, or if it was bigger than the valid range of values. In this case, that upper limit is going to be productNames.count. Because we, in this case, we are working with the one-based index, we have to go ahead and compare it to using the greater than operator instead of the greater than and equal to operator. Because remember, if product names has 5 items in it, the index 5 does not exist in product names. The index 4 does, which points to the 5th element. So under normal circumstances, if the product index to remove variable was one-based, we would have to say greater than or equal to. Because if they entered 5 and there's only 5 items, 5 would be an invalid index. But because we're comparing based off one-based indexes, or indices, then we just simply use the greater than operator. If we successfully enter this if statement, we print out an error message to the user. Otherwise, we actually perform the final operation, which is to remove the product index to remove the index at the product index to remove -1. Again, we have to convert it back into a zero-based indice or index.
I just want to comment on something that was added into the question panel, and that is I prefer BuzzNet for questions, just because other people there can answer them too, and everyone can see my question. And that's absolutely fine. What Nelson was saying earlier and what I've said before is that if you would like for us to answer questions, they need to go over on the questions panel, because it's difficult for us to keep a watch on everything that scrolls by in the text chat. So I just wanted to address that. I mean, if you guys want to throw questions over there, that's absolutely fine.
So we did get a question 46. Allows the user to specify the temp variable of product index to remove. Yes, simply because we pass that argument with the output modifier, which allows the int.TryParse to set the value of our variable to whatever the result of a successful parse is.
And again, we covered TryParse in last week's class, if you want to go back and watch that class. Those that came in starting today that have missed the first couple of weeks, I would highly recommend going back and watch the other classes.
Then what if you don't want the user to remove anything? That is not the behavior of this program per specification. This program, the specification of the program is for a user to enter a product inventory and then remove every item from it until it's empty. I know that doesn't really make sense, but this is an example.
Exactly, it's an example. So let me do this real quick. All hands are now down. If anybody is copying this or want to get this copied, put your hands up real quick. Okay, we've got several hands going up. So Nelson, if you want to go ahead and maximize your editor view. And then...
well, they should already have all that code.
Yeah, that's true. So if you guys need Nelson to move up or down any, you can just say so over in the question panel. I'm going to go ahead and hit pause just for those that are watching this later. We are resuming at this point, and Nelson is switching over to Wolf's screen to answer a question.
Actually, I have to go close my door. I'll be right back.
Hello?
Hey, give us 1 second. Nelson is back. Hey, okay, there you go.
Did I do it right? Do you only have my Visual Studio?
That's it. Beautiful.
All right. Is the text big enough?
Yeah, it's perfect.
All right. I was just saying, I've got the code for the product inventory stuff down at the bottom. I'm not sure if it didn't look like you had it at the bottom, but when I run the code, or when I run the program, can I do that? Can you see that?
Yeah.
Oh, what's going on?
Hello?
Is it on a different monitor?
Nope. But it freaked out. I didn't like that. Oh, nope. It still doesn't like it. All right. Well, anyway, it asked me for the names. I mean, not it asked me for. Okay, let me just stuff through the program. First, it asked me to enter the names. So I enter all the names. Then it shows me what the names are before it asks me to remove it. But I don't understand that because the remove code is in the middle. Right?
Well, if you scroll up on line 33 through 39, all of that code is within the while loop, so it's going to be executing on every iteration.
And that is writing out product inventory.
Yeah, it looks like you have duplicated product inventory presentation code, meaning it's going to. Yeah, down there you don't even need line 61 through 67 because by the time you get there, the product names list is going to be empty.
Okay, just this stuff I can get rid of?
Yeah, because remember that the only way for it to get to that point is to pass through the while loop. And if you look at the condition of the while loop, if you scroll up a little bit on line 30, the while loop basically says we're going to loop over this code until product names is empty. And the first thing it's going to do is it's going to print out the current product inventory, then allow a user to remove an item from the inventory. Then it'll continue looping. Because on line 58...
Oh, that's this code right here. Up here?
Yes.
Okay. All right. Well, that makes sense. That's weird, though, that it's not letting...
And also look for something that may be outside of a loop. Scroll back to the bottom.
Where do... Scroll back where?
To the bottom.
Oh, this?
Mm-hmm.
Yeah, you're going to want to move that to above the loop. Because, again, by the time it gets to that code, it's going to... Product names is always going to be empty. But if you move it to the top of the loop, or sorry, above the loop, then that code will get a chance to execute before you start removing items. So if you just hit Control-C, jump up there, and paste it right. Yeah, but try running it again. I'm wondering what's up with your... Wow.
So screen sharing is now paused.
Oh!
Move this window away from the share to application?
I know what it is.
Well, yeah, because you're constraining it to Visual Studio, which your program when you launch it is a different program, so we can't see it.
Okay.
But I mean, the code looks fine unless I'm missing something.
No, that's... I thought this was all new code. I wasn't really... I guess that's it.
All right, sweet.
All right.
Alrighty, so I can go ahead and I'll switch back. Yes, I want to make Nelson look here, the presenter. And there is my screen. Okay, so quickly glancing through questions.
Okay, it looks pretty good.
All right, sweet. And again, if you're asking questions in the chat, I'm not responding to those, not just because I can't keep my eye on the chat. So,
all right, so that'll pretty much wrap up the discussion on lists, and we will be using lists quite a bit. So at this point, Nelson, we've got two different for-type statements to use, just regular for statements and the for each statements.
Well, did we want to go over the array list real fast?
Oh, that's right. You want to throw that in. I forgot. I'm just going by the syllabus. Perfect. Go for it.
Yeah. Okay. So I'm going to jump back to this example, but I'm going to open up another Visual Studio instance to just kind of show some code real fast. Again, I am going to remove system.link so that there isn't any confusion about the methods inside of these objects. Now, we've seen how we can have a list of ints equals new list of ints, and it uses all this scary syntax, particularly the angle brackets. Well, in .NET 1, there was a nice little class that everybody used that was in the system. So up here on line 2, I'm going to add using system.collections. System.collections has a bunch of types in it that were made before the C# language even knew or was capable of understanding the syntax. You'll also notice that generic is under the system.collections namespace. So generic is a nested namespace within there. But there are also types within the collections namespace. What I'm going to show you is the type array list. I imagine some of you have seen this class before, and if you have not, you will see this class before, and you will be wondering what the difference is between an array list and a list of int. And Segfault, of course, asks, but Nelson, what does it hold? Well, remember, when we specify that this list is of type integer, all of the operations on this list are then tailored to being of type integer, such as .add. When you'll notice that when we say my list of ints.add, we get an int item. We can't pass a string into it. We can only pass in an integer. If we were to make a list of strings equals new list of string, we can add a string. You'll see a string, but we cannot add an int. For example, if I were to add 10 to it, I would get an error. But I could add hey there to it, and that would work. What about ArrayLists? Well, again, ArrayList behaves very similarly to lists as far as how it's implemented, similar performance, and it was in wide use before .NET 2 came out, and a lot of people still insist on using them for some reason that I just don't understand. But I want to point out that these are very bad objects. These are awful objects. The reason that these are awful objects is they have no concept of constraining the type of thing that you pass in. Now, this is horrible, and the biggest reason why this is horrible is because if I wanted to, let's say I wanted to print out a string, or let's say I wanted to loop over my array list, and so I'm going to start with int index equals 0, while index is smaller than my array list.count, index plus plus. Let's say I wanted to loop through everything in my array list and add 5 to it and then print it out. So I'm going to go ahead and say 10 and 5. What I have to do is I have to say int my int equals my array list at index. But here's the problem. You can't do this because ArrayList returns objects, not integers or strings or any other type. I have to do an explicit cast here. So that's number one reason why this is ugly. This is terrible. Then I can go ahead and print right line my int plus 5 if I wanted to, and I can run this and I'll get well, a flashing window. I can run this and I get 15 and 10. But what happens if I do this? My array list dot add hey there. Any guesses as to what's about to happen?
End of the world.
Yeah. Pretty much. Completely valid code, completely invalid at runtime. Specified cast is not valid. So that's one of the biggest reasons why array lists are horrible, because they allow you to do things like this. They also carry no semantic value as far as their types. This has semantic value in its type declaration alone. If I were to hover over this, you will see right off the bat that this is a list of ints. So you know exactly what you can stick in this list. You see right here, this is a list of string. You know exactly what it holds. Carries a lot of interesting value in just the type definition itself. Array lists do not have that. They also will make bugs happen quite often with adding incorrect types into the array list. And it'll also require you to add more code because you have to cast everything that you return from the array list to a particular type. But if the array list holds variables of multiple types, you'll get exceptions. So yes, array lists are bad, and please never use them. Now, you might be saying, hey, Nelson, what if you really wanted to be able to store any type of variable into a list? Should we be able to use array lists then? And the answer is no. Because we can actually replicate the behavior of the array list if we really wanted to, which we almost never ever do, but we can by doing this. List of object. This list of object has the exact same problems as array lists, meaning I can go ahead and say .add 10, and I can say .add hey there. But my point is that the option is available for use on lists, and there's no reason to ever use array lists. And if people do use array lists for homework, then that's an automatic failure, at least if Gavin agrees with me.
I always agree with you.
Okay. So, yes, I just wanted to point that out. If you ever see this in other people's code, just know that this is basically a list that has no concept of what data it can store, but it behaves just like a list. So every data type in C# is an object at heart, yes. Every data type can be stored in an object, which is exactly what ArrayList does. But my point when showing this was that if you really wanted that behavior, you could have it. So the moral of the story is that each type should have its own list. Yes, exactly. That's a very, very good way to look at it. Alrighty, so you think that was clear enough? Is everybody?
That's fine.
Alrighty, so I guess we're going to be talking about for loops now.
Finally, you can introduce these two things, and then you'll be set when you start dealing with collections.
Yeah. So you guys have noticed that I often actually forget to add the index plus plus in a while loop, and that's because while I do use while loops, I don't use them for this pattern here. And the pattern I'm showing you is a pattern where you have an index. So you have three things. You have an index variable, you have a condition, and you have a operation that you perform on every iteration that modifies the index in some way. So how would I change this code to use for loops? I'm going to go ahead and comment that out. And I'm going to go ahead and show what this code would look like with a for loop. Then I'll explain the syntax. Okay, so what is a for loop? A for loop is a loop with three parts inside of the parenthesis. The loop starts with the keyword for, as you see right there, followed by parentheses. And in the past, we have seen this syntax with while loops and with if statements, where you have a keyword followed by parenthesis, and then inside of the parentheses, you have an expression. Then after the parentheses, you have a block of code. Well, in this case, this is a little bit different because this actually has three expressions in it. For loops consolidate your code, correct? Yes, they do. Now, the three parts are separated by semicolons. Of course, the last one doesn't have a semicolon, but still. The first part is the initialization. This code is allowed to declare a variable, or multiple variables if you want to get fancy, initialize them to a value, and nothing else. This part is where you declare your looping variable or variables. This is the condition. So this is what would traditionally go inside of the while loop. As you saw right here on line 38, we have this condition as the only aspect to the while loop, but on line 44, it is the middle expression. The final expression is going to be a piece of code that's going to be invoked on every iteration of the loop. Most often, what you're going to be doing is incrementing your index variable.
Or decrementing it.
Or decrementing it, or adding 2 to it, or removing 2 to it, and so on. However you wanted to do that sort of thing. And Elevating said initialize, compare, action. Yes. That is what a for loop is. After these three expressions, again, this one is done prior to the loop starting, and it is allowed to declare variables. This one is done every iteration of the loop, just like the while statement. Or, sorry, this statement is expression is done before the iteration of every loop, just like the while statement. And this expression is performed after the loop is iterated, but before it's compared for equality. Then the body of this method is basically the exact same as what we saw with the while loop, simply because all the code is really doing is initializing a variable, repeatedly comparing it to another variable, and then incrementing that variable. This is a very, very common use case for loops. Almost always, this is what you will be doing. Now, as far as when for loops make sense, well, this is the easiest pattern to detect. If you are looping through every item in a collection, this is the easiest pattern to use a for loop for. Now, I do want to point out that there is an actual better way to do this, which we'll be talking about very shortly, but this is one of the main reasons why you'll want to use a for loop. In addition, in some circumstances, you might want to loop X amount of times, but not necessarily having to do with a particular collection. let's say you wanted to produce all of the values. Let's say you wanted to produce the Cartesian product of 1 and 2, meaning you're going to get the results, so we're going to get the results of 1, or let's say you want to produce the Cartesian product of 1, 2, and 3, and 4. And so the idea is that we will be creating a combination of everything. So we'll have 1, 3, 1, 4, 2, 3, 2, 4. And so what we would want to do is create 2 nested for loops. We would start with for int I equals 0, I equals 1, I smaller than 3, I plus plus. Then we would say for int j equals 3, j smaller than 5, j plus plus. Console.writeLine, let's just say, we can't do I plus j obviously, so let's say that plus I plus comma plus j. And if we were to run this, we will get 1, 3, 1, 4, 2, 3, 2, 4, just like we expected. So if you need to loop over multiple, a predefined or computed amount of times that isn't necessarily tied to a collection, you will use for loops because they allow you to very conveniently produce results of looping from a number to a particular number and having that number be incremented X amount of times on every loop. So if you have questions, be sure to ask them, because this is a completely, hopefully, a new concept to a lot of people, and we definitely want to make people comfortable with for loops because they're they are a very convenient shorthand for the kinds of while loops we've been using up to this point.
Nelson, for our complete beginners, you should do one more example above all of your commenting. Yeah, right up there. Just something as simple as int I equals 1 and just count from 1 to 5, you know.
So this loop will produce the values 1 through 5 on the console. I got a good question, and please put those in the questions area because I barely saw that out of the chat. Does the int I stay only in the for loop scope? Yes. The int I is declared inside the scope of the for loop and is not accessible outside. What if you wanted to count to 20s by 2s? Good question. For int I equals 1, I smaller than 21, I plus equals 2. Well, yeah, so that's the even, or the odds for this. If we started with 0, we would get even. I cannot see where that output is. Give me a sec.
There you go.
There we go. So we get 0, 2, 4, 6, 8, 10, 12, 14, 16, 18, and 20.
And then just
so is everybody
do me a favor, just for our complete beginners, out to the right of that for line on line 17. We did this previously with letting everyone know that I plus plus was the same as I equals.
Oh, yeah. Good point.
Well, I was going to say that out in parentheses you could do that. Just let people know that plus equals is the equivalent of what Nelson's typing now. So obviously if he did minus equals, it would be I equals I minus 2. Or he could do division equals or multiplication equals. Shorthand once again.
Yeah. So we got a good question as far as what happens if we leave items blank, and the answer is you can. For example, if I didn't want to initialize a variable, we'll see, this is going to be weird. If I initialized a variable outside of the for loop, and then did I smaller than 6, I++, I could if I really wanted to.
Yeah.
Of course, now that I declared this I variable out here, this becomes invalid, so I'll go ahead and call this I2. So I could do this.
And well, you still got a bug, though. Make sure, yeah.
I could do that. I could take out the incrementing if I wanted to. And if I really wanted to, I could take out everything. This is actually something you will see people do. Instead of this syntax, which I think is infinitely more readable, they will do this. If you see this, this is an this is an infinite loop. This is simply saying we are not providing any parts into the for loop. This is perfectly equivalent to a while true. If you need an infinite loop for some reason, go with the while true, ignore this because that's not very clear. Why does that evaluate to true? Don't ask me. The C# developer said if you don't specify a condition, it evaluates to true. Well, okay, fine. The don't ask me wasn't literally do not ask me. It was in the context of, honestly, that's the decision of the language developers. They could have just as easily made the specification say that an empty condition would be false, but in that case, then that would be even sillier than it already is for it to be true. Frankly, if I design the language, I would say that this is invalid code and that you must specify a condition, at least. Can you do by powers? NATO, you brought up a good one. You can, but this is not how you do it. You will go insane if you tried. This is not the. This will not actually perform a power operation. This will perform a bitwise XOR operation. If you wanted to do it by powers of 2, you could say I equals math dot pow, and then pass in I and 2, if you really wanted to. And of course, I'm going to have to convert this into an integer because math.pow returns a double.
He wasn't covering bitwise. Just
no,
the word slipped out.
I just wanted to point out. Yeah, sorry about that. But I just want to point out that this has nothing, absolutely nothing to do with powers at all.
I love the English language. I thought you was about to say, this has nothing to do with that. Wait, this has everything to do with that when we get into dealing with, Yeah,
I try to catch myself on the infinite loop there.
Yeah, that's good stuff.
So I just wanted to point out that math.pow is how you perform powers. Okay. So, is everybody good with what I have on the screen? Does anybody have any more questions about how for loops work, what the different components are, and the behavior of a
So here's a 5-second test for you. This should be a very quick one that you can throw into your code. Everybody throw your hands up. Seriously, everybody should be able to knock this out fast. Hands up, hands up, hands up. Meta, yours too. All I want you to do is a for loop that goes 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Just a little countdown. So simple. Oh, God, Dosage, it's so difficult. Do it. So just think about your initializer, what you need your starting value to be. You need to increment or decrement. We want to count down. And as soon as you get it done, put your hand down. Toastich never even put his hand up. You know, Toby, we really could teach you how to program. We could, man. We so could. And with the crazy way you view the world, oh, man. The applications you could write would be insane. Yes, Florm. Very, very simple assignment I just gave everyone. All I want people to do is write a quick for loop that simply counts from 10 down to 0. Toasted, you're making things too complicated to start with. Okay, so remember, once again, once you have it written, put your hand down. Good afternoon, Mr. Brasher. Okay, so most of the hands are down. Nelson, go ahead and code this out just nice and slowly. Go ahead and cut or copy line 16 and paste, or line 18 now, and paste that above. So we have another separator. All right, so for those of you that might have a little bit of difficulty with this, no problem. Just watch what Nelson's doing here. Think about the logic behind this. Toastage. Throw in equals in there, because count all the way down to 0.
Oh, I thought you said
10, 9, 8, 7, 6,
I
5,
thought
4,
you just
3, 2, 1, 0. And run.
Okay.
And there we go. So let's take a look at the code real quick. So again, for those of you that are still really new to working with the for statement, it's divided up into 3 parts. The first part being our initializer. So inside this part here, Nelson has declared an int, and he set it to a value of 10, since we know we want to count from 10 backwards, 10 down to 0. The second part, the 3 different parts in the for statement, are divided with terminators, or semicolons. So the second part is our expression, our test condition on if we're going to do what's inside the loop or not. As long as this value, or the expression evaluates to true, we're going to do what is inside the loop. So right now we know I starts out at a value of 10, and 10 is definitely greater than or equal to 0. It's greater than. So we are going to do what's in the loop. So from here, it actually, don't even look at that part yet. From here, what happens is we're going to run the console line. Can I have mouse control for just a second?
Yeah.
Thanks.
Okay, should be good.
All right, let's see if it works. Okay, sweet. Yeah, I got adjusting to lag. So again, we initialized. This happens first time when we hit our for loop, our variable, local variable to the scope of 4, so only inside here, I to 10. And then as long as I is greater than or equal to 0, we're going to do what's inside the loop, and it's 10. So we're going to do everything that's inside the loop. It's only this one statement. So we write out whatever I is right now. And what is I? It's a 10, so 10 just got written out. Where are we at? We're now at the end of the loop. So this is what happens with the for statement at the end of the loop. We come up here and we hit our incrementer or decrementer. In this case, we've got a decrementer in there. I minus minus is the same exact thing as we've said last week. I equals I minus 1. So we just subtracted 1 away from I. So if you recall, I was 10, so I just became 9. So after we manipulate the value here, then we come back over and we check the expression again to see if it's true and if we need to do the loop. Well, 9 is still indeed greater than or equal to 0. So once again, we're going to print out whatever is an I. So it's going to print out a 9 to the console. We're at the end of the loop. We come back up here once again. We decrement I again from a 9 to an 8. Then we come over and we check and verify that, yep, 8's still greater than or equal to 0. Console right line out, so an 8 gets right out to the console. We're at the end of the loop. We come back up so you can start seeing the looping pattern now. So we take I, we decrement it by 1, so I now becomes a 7. 7's still greater than or equal to 0. So we write 7 out. End of the loop. We come back up, so let's pretend this happens. So we're all the way down to a value of, let's say we're at 1. So this decrements 1 away from 1, which is a 0. Again, we come back over here. 0 is indeed greater than or equal to 0. It's equal to itself, so it's still true. So we're going to console right line out 0 because that's what's in I. We're at the end of the loop. We come back up again, and we take I, and we decrement it again by 1. So now we have a negative 1 in I. So we come over here. Is negative 1 greater than or equal to 0? No, it is not, meaning no, we're not going to do the contents of the loop. So we simply skip over and we continue linear execution after the for statement. And that's what's going on.
All right. While you were explaining that, 2 good questions came in.
Okay.
Unless you had anything more to say.
Go ahead. I just wanted to go through it real slow for those that are really new to this stuff.
Alrighty. Why do a lot of programmers use I and J in for loops? They're not very good variable names like you always tell us to use. The answer to that question is historical. There was a language, and I can't remember the name of that language, that restricted the variable names that you could use within the looping construct to be I, J, and a few other single-letter variables. And historically, that tradition has carried over to this very day. And if you see a person with a for loop, because you've written and read so much code, or well, at least, well, because I've written and read so much code that uses I as a counter variable, I'm accustomed to looking at that, and it actually does carry. When in this context, it does carry the exact same semantic value as a int index equals 10 would contain, simply because that is a convention that's been established for so long. Furthermore, for loops should be, or looping methods in general, should be very short, meaning the local variables that you declare, while they should definitely have good names, you should always be able to see your counter variable, or when your counter variable is being declared, on the same screen of code as you see its usage for. And so if you see I being used somewhere, like I said, that carries the same semantic value as the word index, simply because of the historical reasoning behind it. So is everybody good with that explanation? Obviously, if you name something I that wasn't an index variable, that would be bad, because first of all, single name variables are often bad, or almost always bad. And then second of all, the variable name I has special meaning to programmers. Same with J. I and J are very commonly used for counter variables, so commonly that they mean just the same thing as the word index. Yeah, and then if you're doing a for, like Segfall just pointed out, if you're doing a for loop, let's say you're looping over all the pixels on your screen, in that case, you would want to pick a better variable name, being X and Y, specifically because you are performing operations using the X and Y coordinates that are being produced by your for loop. In that case, the value that you get through reading the variable names is equivalent to if you had named them something else. Yeah, I think K also is used. I and J are the first two that are used. I've seen K used as well. but I'll very rarely have 3 nested for loops. Very rarely. The good thing, another thing that came in, for loops execute at least once? No, they do not. For loops will not execute if the condition is not true. Same behavior with while statement.
That's why when I was
However,
demonstrating it just a second ago, I was showing initialization, then check, then we go in,
right.
and then at the end of the loop we bounce back up, decrement or increment, and then back over. Kind of the pattern in which execution happens.
Yep. Wendy Butt asks, does the I still exist after the for loop has finished in the chat instead of the webinar questions? And the answer is no, it will not. Can you have an infinite for loop? Yes.
Oh, yes.
If your condition doesn't ever become true, like if this was while I does not equal 11, I mean, that will eventually result in either exception or wrapping around, but it still won't have the behavior that you expected. Of course, an infinite loop would be either specifying true as the expression or simply omitting the condition entirely. All right. Is everybody good with for loops now?
Hopefully that helps out a little bit. Hopefully you guys can see why we did the little simple 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0 example. Just a good way to get your feet wet when learning this stuff.
Yep. And Toastage just asked another question inside of the chat. So does a for loop need 3 arguments? No. Well, yes, but they can be empty. The 3 components of a for loop, the initializer, the condition, and the action, can be empty, but they must exist. And the fact that there's this semicolon right there defines its existence. Question, can we do something when I reaches 0, can we say the program is done? Well, certainly. If you were to, I'm going to go ahead back over to another Visual Studio window. If I were to say in this program for an I equals 0, I smaller than 10, I plus plus, because there's nothing following the for loop, the program will terminate at the end of it. However, in this case, because there is additional computation that needs to be done after the for loop exits, the program will continue just as normal. Can you have more than one condition in a for loop? Another good question. Yes, but not, well, again, yes and no. It's going to be the same condition, but you can always use the AND operator. Like if I had like int j equals 0, and then, I don't know, j equals int dot, this is really convoluted. So this really shouldn't be j. This should be bleh. And bleh does not equal 3. Well, I'm not using this variable as a counter, so I don't want to use j. So this is how you would perform more than one condition inside of a for loop. You'd use the AND operator. Can you show multiple var initializations and multiple actions in the for? Sure. I can go ahead and say int I equals 0, j equals 0. And then I can say I plus plus, comma, j plus equals 2. And then I can go ahead and say console.writeLine I is I and j is j. So yeah, in this case, you'll see that these two things are separated by commas. Alrighty, are we about ready to get on to for each loops?
I think so.
Okay, so I'm going to go ahead and nuke all this code on the top because that was just example stuff for loops. Because now we're going to be talking about for each loops. Now this pattern is so common, so incredibly common, that the C# language actually provides even a further shorthand for it. Now for each loops aren't just a shorthand for this particular syntax, but they do provide one. For each loops are very powerful looping constructs that can be used to do lots of cool stuff. But they're a lot more complex than our other for loops, or our for loops and our while loops, because it does a lot of things behind the scenes for us. If I were to show you what a for each loop looked like, I first want to point out the goal of what we want. We want to loop over every single item in a collection. We want to loop through every single item in a collection, and we want to get a variable out of the collection on every iteration. So instead of having to do product names at index, we can simply get a variable that's already assigned to the current product name at a particular index here. Well, this is a bad example because I still need the index, but whatever. Yeah. Actually, I'm going to take out that for now. We'll talk about ways to get that to appear later. I just want to point this out right now. Okay. So for each loop, what does it do? Well, what does it look like first? Looks like just basically the basic sort of pattern that if statements, while statements, if for statements already follow. But in this case, we have the keyword for each. Now, for each is going to be followed by parentheses again. But what goes in the parentheses is very strange looking. There's two parts to these parentheses, or to the expression inside the parentheses. It's not really an expression. The syntax is only valid inside of for each loops. The two parts are the variable and the collection, separated by the in keyword. This variable is going to be a variable that is automatically set to every item in the collection that we're currently looping on. So basically, we say for each string product in product name. So it reads really well. For each product and product names, do blah. And this is what we're doing here. We're just simply writing out the product. So in this case, I mean, there's so much that's happening behind the scenes here, but that's not particularly relevant, at least as far as usage of for each loops go. They're very powerful and straightforward and easy to use when we're working with any sort of collection object. And this includes arrays. Arrays will work with for each loops just like lists will. In fact, every type, or I'm fairly certain every type, under the system collections generic and system.collections namespace will allow you to use a for each loop. So the idea of a for each loop, again, just to reiterate, is we're going to loop over every single item in the collection, and on every iteration we are going to alias out the currently selected item into a variable of our choosing. And in this case, it's going to be named product, and it's going to be of type string. So that's the first really important thing about the for each loop besides the syntax. And the syntax, of course, is very important. We must have a variable declaration here, and we must have a expression here that evaluates into something a for each can process. Someone just asked, collection is a generic term for arrays and lists. That gets into something that's kind of complex. I'll try my best to that terminology is very sticky because a collection class will generally be considered to be any of the types, the special types that allow you to add more than one item to that allow you to create a list of something like an array and a list and stuff like that. But typically people do not refer to arrays as collections. That being said, arrays do implement some of the same functionality that that makes the other types collections. So saying an array is a collection, I generally would not use that. If I was talking to another programmer, I would simply say array if I was referring to array, or a collection if I was referring to anything under the collections namespace. I know it's kind of funky, but still. So yeah, so that's the syntax of this, and that's what this code does. If we were to run this program, of course, it's not going to look right because we don't have the index values there. But I just want to point out that that's the result that we're going to go ahead and get. If I wanted to add in those indexes again, I have two options. I can either do the for each loop like we had before. However, I will generally do something like this. I don't know about you, Jason. Oh, come on. Thanks for catching that.
There you go.
So there we go. So that's what I'll generally do. Simply because the for each loop is very powerful, and furthermore, it allows us to loop over collections that don't have an indexer operation. We'll get into that once we get to more types of collections, but there are some collections that we cannot physically access by index. We have to use another means to access it. The beautiful thing about a for each loop is that it's capable of understanding virtually any type of collection or array that you might throw at it, which is really awesome. Yeah, the segfault brings up the linked list. So right here, you'll see that I have declared this variable a particular type, and I declared that type string. If I were to write int, there would be an issue. And the issue is product names is a collection that has been typed specifically for strings. Because integer is not compatible with string, the for each loop will actually throw an exception or throw a compiler error saying that cannot convert type string to int. So this type that you specify as your temporary variable must be the same type that the collection is capable of producing for you. So is everybody good with? I mean, see, I don't know at this point what to go into more detail about, or.
I would just wait to see if there's any questions. As a matter of fact, now is a good time to take a break because we're at about 2 hours and 10 minutes, and we are getting close to the end of all of the content, ladies and gentlemen. But this is a good time to take a quick break, and then if you can think of any questions to try while or to ask while on break, please add them into the questions panel. So yeah, let's go ahead and take a break.
Sweet. I'll be right back.
Okay. Welcome back, ladies and gentlemen. We are resuming from the break, and let's go ahead and get started.
Okay.
So, let's see. Any questions that came in? Looks like there might be a few questions that came in during the. Let's see. I was looking about last OpenOffice hour session. I can't find it. That's because it's not been added into the streaming system yet. It will be put up, but this last one there's very little value in it.
Yeah, most of it. I mean, there is ILSpy. I mean, that's kind of fun, but not very valuable to.
But it will be put up. My heavy
somebody asked
activating the mic. Whatever. Wolfrey, is that you? So let's see. Will I lose attendance due to being late? No, Mr. Ian. You have nothing to worry about, sir.
Also, a question did come in about if you can do something like this. And the answer to that question is no, you cannot. So just a heads up, it is impossible to do that in C#.
What you just did was so funny. Nobody's even going to laugh except me, but it's just the way my mind works. You said, we did have a question that came in, and somebody wanted to know if you could do this. And now if you just had your eyes closed and you didn't see you actually typing anything out, your keyboard's so loud, it sounds like somebody tap dancing. It's like, and somebody asked if we could do this. And I just pictured you tap dancing, which was the funniest damn image I've ever seen come to my mind before. So, yeah, I'm sorry, but that was a funny image. I just thought I would share. So the answer is no, you cannot do that.
Yeah.
So continuing right along.
No, the answer is new.
Yeah, exactly.
Yeah. So yeah, you cannot do that operation there. Another question came
But
in.
you can go ahead and say what Segfault did mention about, but you can use var. And because we have lightly discussed var. So
Yes.
you can get away with doing that.
Mm-hmm. Because product names is actually typed to string, the C# compiler has enough information to implicitly determine what the type of the variable in the for each loop that you want to use. So yep, you can use var. And again, I would be using var if this wasn't an intro to C#.
Yeah,
because I want everything to be as explicit as
and
possible.
Don just asked that question over in the questions panel, and it's a great question. We would be using var for everything. So yeah, everything that we can, every local variable. That's correct.
Do you know why they decided not to use var for the
Fields
automatic implementation? In
Automatic
the automatic implementation of for loops, it comes up as int rather than var but it does the same in ReSharper and in IntelliSense.
Yeah, ReSharper does do that. It's funny. ReSharper will generate a loop for me and use explicit typing, and then it'll
turn around
tell
and
me
complain?
to use implicit typing.
To change it, yeah.
Because that's how I have it set up. So, yeah.
Real quick, go ahead and go back over what var is for those that, like Chuck is asking again. Just real quick.
Yeah, var is called implicit typing. Var is not a type. It is a C# keyword. And var will simply make this variable declaration at compile time be equal to whatever the expression, the type of the expression is that we assign it to. That means that we cannot do this.
That's correct.
Simply because the C# compiler has no way to determine what the type of this variable is.
And you may be thinking, even if later on we say my invalid var equals 10 or 20 or whatever, you still can't do it. Yeah, here you go.
And it really is, it's the same as if you looked at it at that point in time, could you determine what invalid var is? No,
Exactly.
You couldn't, because you haven't got enough information.
Right. The compiler is actually going to look at it.
If you can determine it, the compiler can.
Yeah, it's going to look at it during declaration, and it has to be initialized also, all on the same line. So go ahead and make it valid real quick by...
Yeah. If I were to take this this initializer and do it on the same line as the declaration, the C# compiler will properly type this variable to system.string, simply because it has enough information at this point to make that determination. And again, just for people who are wondering this, which there are 0 of them right now, is there any language that is capable of allowing you to do implicit typing when there isn't enough information at the beginning? And the answer is yes. F# is a language that does as much implicit typing as it can, and it will look forward and backwards to determine the types, and it's very, very interesting. Roland Stone says Python. The answer to that question is no. Python is dynamically typed. See, this is not dynamic typing. This is implicit typing, but it's still static, meaning that this has absolutely no difference than if I were to simply have done that. As far as the code is concerned, as far as performance is concerned, as far as the IL generated is concerned, these two things are the exact same, and they're all statically typed. Now, yes, there is this, but we're not talking about that.
No, that we're going to avoid right now.
So var is just a C# keyword. It's not an actual type. Okay, so I did actually have a question earlier than that I wanted to
before you get to the one
answer.
from Dave?
From Dave.
Yeah, okay.
Where is it? Where is it? Where is it? Where is it? Okay, so somebody asked something like this. Can I have a list of strings, or sorry, ints, and do this? The answer is no. Sorry, that answer was yes. I didn't mean to put in var. That was just my automatic typing, thinking and typing at the same time sort of thing. The question was if I could do this. If I had a list of ints, can I have the type of my variable instead of the for each loop be a string? No, you cannot. And remember, if you ever have questions like that, you can always just type it in to see if it will compile. But the answer is fairly straightforward in this case, where my ints is typed to the type of int, not to the type of string, so for each cannot in any way allow you to loop over it.
But you could still use ints and turn around and use toString to...
Yeah, sure. We could say int, in that case, that variable is not bad. My int, and then we can say string, my string equals my int dot toString.
And I would say I more than any other program where I'm hovering over Control S at all times to save. After pretty much every line I write, I hit F6 in Visual Studio to build it and see if it compiles in case I've made a stupid error. And it's a lot easier to catch them one by one when you've only got a couple of lines of new code to look at than it is when you've got an entire class or even just a method to look at.
That's definitely a good point. There also is in ReSharper, there's a window you can open up called Errors in Solution, which will, if you open up that window and leave it around, it'll actually show you in real time any build errors that you might have, which is very cool.
I just like the fact that when you hit F6, it saves it as well, so it's killing two birds with one stone.
Yeah, that's true. Okay, so somebody said something like this. Somebody said, can you briefly explain why var productNames equals new list of string will work even though it doesn't seem to assign any value? I'm not entirely sure what that question is or what you're asking there.
Since you're not putting a literal, like a 10 or a literal string.
Ooh, okay, that is a good question. Well, yeah, it's like, check this out. This literal has a type, and that type is system.int32. We could do this. Or, sorry, that doesn't have a constructor. Really? I could have sworn it did. String does. We could do this if we wanted to. Just instantiating it out long way, or not. Does that not have a... Oh, that has a character array. But you would never want to, which is why I've never done it. So you actually can't.
Something magic.
Yeah, want to see a magic trick? My point was saying that these string literals actually do go out and instantiate, or not necessarily instantiate, but in this case it kind of does, an object, just like what you have here. And what you have here is an instantiation of this type. The value, the type of this expression is going to be whatever type you instantiated, which in this case is list of string. So this expression has a type. Therefore, the compiler can correctly determine on the left-hand side that you have a type of system.collections.generic.list of t, and then it says t is system.string. So it determined that because this expression does indeed have a type. Does that answer your question? Sweet. All right, I'm going to go ahead and nuke this code and ask if everybody is fairly comfortable with what you see here.
You know, you may have
put your hand
you may
up.
have to give it some practice after hours, but
yeah, I'm going to put everybody's hand down and put it up if you have a question that you're typing out or planning on typing out or anything like that.
okay, I think we can move on over to the final thing for today.
All right, sweet.
Which will be switches.
Okay, so what's this? What's a switch statement? A switch statement is this. Actually, hold on. It's a little bit nicer. I'm just going to get the syntax out of the way, then I'll explain it.
Everybody go ahead and put your hands up too. We'll let everybody type this out so that you got an example.
In that case, I'll use better messages.
Faster, faster, type them out. Da, 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 da. Hands up, hands up. Oh, you guys are slow. JT, it's not that late, is it? Brislin, man, come on. Get those hands up.
See, in my head, I kind of picture Brislin in slow motion.
Do you now?
Yeah, it's just like camera visual, effects slow motion.
You know, he might actually just be asleep right now. He could just be snoring.
It's that huge voice. Kind of.
He's running toward you through a field of flowers. Disturbing.
With an axe.
Yo. Okay, so get this typed out.
I mean, I guess we could maybe pause the
Yeah.
recording, or unless anybody has something I can talk about.
No, I'll go ahead and pause it, and let's let most of the people get their hands lowered back down once they have this typed out. Then we'll go over syntax. Resume. All right, we have resumed.
Alrighty, so we have a switch statement. A question came in, what can you switch on besides C# besides ints? Well, before I answer that, actually, I think I'm going to define the syntax here. What's happening is very similar, again, to kind of how things work, where, oh, somebody did just answer another question. I know I just did the whole first in, first out thing again, but what do you use that you need VMs to run in Visual Studio? The reason I have that is my Visual Studio install has a bunch of add-ons and other things. It's also the Ultimate Edition. I wanted to use a C# Express edition with all the default settings, or at least for the most part, for people watching the class. Okay, so we have a switch statement. Again, it follows the same sort of pattern that we've seen with everything else. We have the keyword followed by parentheses. And then inside the parentheses, we have something. Then we have a block. But inside the block, we have some weird things. We have these cases, these breaks, and this default. What's going on here is I'm going to define this a little bit further in a moment, but simply think about it that we are comparing this same variable to multiple possible values. We're basically making a bunch of if statements. If we were to write this as an if statement, it would look like this. If my option equals 1, then first option. Else, if my option equals 2, second option. Else, if my option equals 3, third option. Else, default option. So that's basically the equivalent if statement. Now we could have done an else if, like Elevating said, and it would have looked a lot nicer, but we haven't really talked about else ifs yet, or doing a single statement of statements, just to keep things simple. But hopefully by now everybody is good at being able to identify how this code works, or at least what it should be doing, because we are, comparing my option to 1. If it's not 1, then we're comparing the option to 2. If it's not 2, then we're comparing it to 3. If it's not 3, then we do the default. So inside of the switch statement, we're doing something similar. We're switching on my option. In the case that it's 1, we perform this block of code. Now, instead of using curly braces to define this block of code, switch statements look a little bit different. They use the break keyword to denote the end of the block for this case statement. So in this case, case 1, the block starts right here on line 40, and the block ends on line 41 because we break out. In this case, we have case 2, followed by the console.writeLine second option. So the statement would be on line 44 will be executed in the case that my option is 2. And then we define the end of the block by specifying the break keyword. This game, same sort of deal. If my option is 3, we write out third option and we break out. Finally, we have a special type of case in here called default, which is just the keyword default followed by a colon. And this will be executed if none of these other cases were matched. And in this case, it'll just print out default option and then break out. So if I were to go ahead and run this, if we type in 2, we get second option. If we were to type in 3, we get third option. If we were to type in 4, or if we were to type in this, we would get default option.
Do you want to put an extra line of code in one of those just to demonstrate because of the non-bracketing, whatever they're called, curly bracing?
So something like first option line 2.
Yeah.
So now if we type in 1, we'll get first option followed by first option line 2. As you see, execution begins here on line 17, continues into line 18, and then finally exits on line 19, and continues to brings execution back to the end of the switch block, which in this case will be line 34. Okay. Is everybody good with this so far? I saw the question about switching on different types of data, and I'll talk about that in a moment when I get to the limitations of the switch statement. But if anybody has any questions about switches in general, now's the time to ask them. Why do switches have this syntax instead of curly braces? It's a readability thing or a legacy thing? I don't know. Ask the language designers. Probably just more of a legacy thing, I imagine, because this is how switch statements look in a lot of different languages. This way a while till you're done explaining to the others, or this can wait till you're done explaining to the others, but can you skip call cases? Like case 1, skip to case 70? No. You cannot, I can't say go to case 3 instead of a case statement. However, I can do something called following through. If I were to say something like this, case 4, console.writeLine, fourth case, and then I could say case 5, I can say console.writeLine, fifth case, because I did not have a don't tell me you can't fall through in. Really, you can't fall through in C#?
You can, but not if you've got code in there.
Right, you just have to have case 4 stacked like that.
Right. This is actually something I was going to bring up at the end, the fact that I don't use switch statement cases at all. But now if we do 4, we get fifth case. And if we do 5, we get fifth case. So, Stuart, the answer is no. It will in many other languages, which is why I assumed that it would work in C#, but the C# compiler knows better about what it's capable of taking in. For the cases, could you use Bool expressions? No. That comes into the limitations of case statements. Yes, you can fall through in C++, or you better be able to.
But you could switch on a bool.
Oh, sure, you can switch on a bool. You can say, this is kind of silly, you could say switch my option equals 2, case true, bleh, break, case false, bleh, break, which would just be kind of silly. Because an if-else is much more readable in that case. Okay, so somebody was asking about other types in switch statements. The limitations of switch statements, there are quite a few. And the main limitation, and these limitations are one of the reasons why I don't use them, why I prefer ifs and else ifs. But switch statements must have to be a sort of constant value, but they can be of almost any type. So for example, or any type that you can have a constant literal of. So for example, we could say, we could pass in a string if we wanted to. We can say console.readline and then do, you'll notice that all of a sudden all my cases are now invalid. But if I were to do 1, that is now valid. 2, 3, and so on. This is valid, and the reason this is valid is because the C# language has a literal expression that evaluates into a string. So you can switch on enums, which we haven't covered yet. You can switch on pretty much anything that you can represent as a literal value.
I was going to say, would enums be the place where you're more likely to reach for a switch statement, or would you just still not like using them?
The only reason I would use a switch statement on an enum is I have used them in the past on enums, but because ReSharper can generate all the cases for me.
Yeah.
As far as what expressions you can have here, he said something. Someone asked if you can do this. And the answer to that is no, because in cases, inside of cases, they must be a constant, they must be an expression that turns into whatever we're switching on. So that doesn't really make any sense. And in this case, you'll see that a constant value is expected. So you're not even able to do expressions that evaluate into the proper type, which makes them very limiting.
Okay, are there any more questions? I mean, it is pretty straightforward.
Yeah, it is straightforward. I don't find myself using them. Maybe one of the reasons why I don't like them so much is the level of indentation that they create. And furthermore, one of the things that they encourage people to, they tend to encourage people to write a lot of code inside of their individual cases. And that makes things very unreadable very quickly when you have a lot of code inside of your cases. So it can't be constants, but it could be constant values. It can't be expressions, but it can be constant values, yes. So as you see, because C# has a constant, is capable of understanding strings in a constant context, we can perform switches on strings. But you wouldn't be able to perform switches on like a list, for example, because that doesn't make any sense. And there's no way to represent a list in as a constant value. Yes, if-else's allow you to do whatever expressions that you may want. They're infinitely more flexible, and in my opinion, more readable because they result in less indentation.
But it's still something that I feel that they should see.
Andrew posted a question that we both know he knows the answer to, but it does bring up an interesting thing we might be able to cover, Jason, if you agree.
Yeah, I was actually thinking about suggesting it earlier when you there was a couple of instances where you put yourself into an infinite loop that breaking out could be, somebody might be wondering how would you ever get out if it's infinite in those particular cases.
Okay. And before that, there's a quick question about performance compared to if-else. There's no performance difference. If you did an if-else and you were just comparing one value to constant values, then there's going to be the same IL is going to be generated for a switch than an if-else. Okay, so Segfault's question was question about loops. Is there a way to break out of a for loop halfway through? Answer is yes. Every looping construct is capable of being broken out of or continued forcibly. Before I get into that, I just want to make sure that everybody there's no more questions on switches. So put your hand up if you have a question on switches. Otherwise, we're going to be moving on to some looping stuff. So, TJ, did you have a question, or did I just not see the question that you posted? Okay. Well, in that case, let's move on to breaks and continues. I'm going to leave this up, this Visual Studio instance up again, just in case somebody asks about switches again. Now, when inside of a loop, let's say a while true loop. Now, you might be asking, why would you ever do this? Because this loop will never terminate, ever. It'll continue on forever. But I'm going to go ahead and show you how you can make this valuable. So I'll start with a console.writeLine and a console.read key at the end. So once we reach the end of the loop, these two statements will be performed. Now, there might be a situation where we might have something like string input equals console.readLine. I might say if input equals quit, how at this point will we actually exit the loop? Well, there's a handy little keyword called break, not to be confused with the breaks and switches, even though they perform similar operations, but break can be used in any loop. You can use them in while loops, you can use them in for loops, you can use them in for each loops. And do while loops, which we haven't covered yet. So breaks can be used, and you'll see that Visual Studio is helpfully highlighting the break or the while loop that is going to be impacted by this break. And what's going to happen is, a question just came in, is it similar to the return keyword? Kind of, sort of. You can think about it like when this break statement is hit, the closest loop that we're in is going to be terminated immediately. So even if I had code down here,
but it's not like we return back to the call site.
it's true. So if I was to say stuff and things, and then I was to type in quit, you'll see that we never even got to line 20 when I broke out of the loop. We immediately continued execution on line 23. So those are breaks.
Did you, because you said not to confuse it with the break used in switch cases, how does it differ? Because it seems to have this same
It's very, very, very similar, but the breaks in switches are mandatory, and they kind of, they just feel different to me. I don't know. And they're mandatory.
It does the same thing. I mean, it will leave the construct, but the key thing that Nelson's getting at is they're mandatory.
Yeah, I just didn't know if there was some obscure usage.
No,
I was unaware of.
They're required.
Okay.
Okay, there's one other construct similar to break that we can talk about, and let's say we wanted to say if the person typed in skip, what we want to have happen is we want to skip all the way to the top of the loop again. We do not want to execute line 26 or anything that is outside.
Anything else?
Anything
else in the loop that's after this point.
Yep, we don't want to execute it. What we do is we type in continue, and again, continue will highlight the parent loop that we are going to continue out of, and it will just go ahead and reiterate on the loop. So now I can type in, hey there, stuff and things, but if I were to type in skip and hit enter, you'll see that the console.writeLine never got executed. So I can keep on typing in skip, skip, skip. But if I was to type in skippy, it's going to go ahead and write that out because that doesn't match the condition on this if statement. And then finally, if I were to type in quit, I will finish the program after immediately. Break is used to exit loops, but what about return? Return is going to make a whole lot of more sense.
Yeah, after next week.
Lesson.
Let's wait on that, Nelson, because that has to deal with actually getting into methods.
Okay.
Yeah, that's very applicable and one of the things we will be talking about next week.
Does plain Visual Studio it'll show you
awesome.
show you unreachable code?
The C# compiler will. Sometimes it'll be
I was just looking after that continue statement, for instance.
Well, that's not necessarily unreachable code, because if input did not equal skip, it would be reached. But if I were
inside the if.
Oh, right. If I were to go ahead and say console.writeLine, hey, I know ReSharper will, but I haven't used Visual Studio without ReSharper for so long. Unreachable code detected. Yeah, the C# compiler itself will. So if I actually open up my my error list, it'll actually show me a warning. Unreachable code detected.
Yeah, I'd forgotten whether it did or not.
So,
but ReSharper does a lot better job at it.
At this point, I think it's a good spot. While people might be thinking up of any questions, I think it might be a really good spot to go ahead and start going over the homework.
Okay. Well, this homework is going to be very interesting.
Dun, dun, dun.
So we started off the first homework with a very basic program. Second homework with actually a rather fairly complicated thing to do for beginners, but it's definitely something worth aspiring to being able to put together. But this time we're actually going to be building, now that you have all of the tools you need to do this, we're going to be basically building a simple game. A simple guessing game that has some interesting rules. Now this game, I'm sure it has many different names. The name I've heard is called Hang In There. What it does is the computer generates, actually we do need to talk about this one. Really quickly.
Okay, go ahead.
I'll just say computer generates random 3-digit number. But here's the code to do that. I'm not going to go, why did I do that? I'm not going to go over the intricacies of what's happening here, but this is very important to be able to actually do the homework. Just remember the following snippet. If I wanted to generate a random number, I can do so with the random class, but I have to instantiate the random class. So basically, this is what I'm giving away here. This line goes on the first line of main. Just do that, period. Use this line to get a random number.
While you're still typing, there's something that occurred to me I hadn't had a chance to mention, which is we could provide a program.cs with a space for their code to go.
What?
Yeah.
We could, or they could just type those two lines out.
As a general thing, I'll talk to you about it later then. But there's other logistical reasons why it would help further down the line with more complex programs.
Okay, so then I can go ahead and say console. Actually, I'm going to go say while true console write line. I'm going to take this line and stick it in this while true method just to prove to everybody that this is how it works. Oh, come on.
So every time he's hitting a key, it's generating a new random number.
Yep. Okay, is everybody good with these two lines? You don't have to understand how it works or the intricacies of how it works or anything like that. This will be in the video at the end of it, so definitely check it out. Actually, this will be in the homework submission thread, or the homework definition thread. So, but is everybody kind of comfortable with what we're doing here?
It's just he's giving you the code for how to generate a random 3-digit number.
Okay. So the definition, or the game that we're going to go ahead and be writing, is going to be, again, called Hang In There. That's what I've heard it referred to as. the idea is the computer generates a random 3-digit number. Then the goal of the game is to, well, guess the 3-digit number. But here's where things get interesting. The game it allows you to enter a number, a guess, every iteration of a loop until you get until you finally guess the real random 3-digit number. But what it's going to do is present you with a user interface that shows you all of the previous attempts that you made. And it's going to put it into 3 columns. Not close, close, and hang in there. So for example, if I were, I'll actually fill this up with a real example in a second after I define what's supposed to go in these 3 columns. The not close column is going to be if your guess had no digits if your guess didn't have any digits that exist in the goal number. Close, if your guess had digits in the goal number, any amount, but were not in the right place, value. And then hang in there, which is going to be if your guess had digits in the goal number and at least one was in the right place value.
Yeah, like Sigfrid said, it's Mastermind.
Okay, so if I were to, for example, let's say the goal number here is 532. Let's say I guessed 123. That's going to go in not close. Then let's say I guessed something like 2. Oh, sorry, that's going to be close because there's a 3 in there. I can do basic comparisons in my head.
Yeah, do you want to just do these on new lines?
Okay, yeah. So the first step, I do want the thing to re-render the entire UI on every iteration. But for clarity, I'm going to go ahead and put each guess on a new line. So if, let's say, so not close is going to be something like 6, 7, 8. That's going to be not close because there isn't a 6, 7, or an 8. Let's say the guess was 6, 2, 8. That's going to be in hang in there because the 2 is in, or
no, it's not.
No, it's not.
6, 8, 2.
There you go.
Because the 2 is in the correct place value. So, and then if I were to guess, and so on and so on. Basically, you get the point.
And of course, the goal is
What happens when you get it right?
you win.
Oh, if you get it right, you win. It says you win.
And how many tries?
Also, exactly. Game will exit when you guess the number and output how many tries you needed. What I mean by re-rendering the UI each loop, I mean this isn't the output that I'm expecting. I'm expecting these to be all in the same line because I want every iteration of the loop to write the header, to write this, well, however you want to present it. You can present it as fancy as you want, really. So there, I made it a little bit fancier. You can have the output be as fancy as you want, but I want the entire, in fact, I want the screen cleared. That method is simple enough. I doubt it requires explanation. But at the end of every loop, I want the screen cleared, and then this to be completely redrawn out to the console. And to not have any spaces here. So 6, 7, 8 would actually be up here. If I had 2 items in the not close, then this column would be 2 items long. So, I mean, I'm just going to assume that everybody's good on line 19. I mean, Jason, is that a fair assumption?
Yeah, I would leave it. I would leave it there,
there.
but yes, it's just clearing the console.
Okay.
All right. So, if there are any questions, now is the perfect time. Toss them in.
Don't delete that, Nelson. Don't delete that, by the way.
No, I was going to shoot it over to you.
Okay, cool, thanks.
Can you tell me?
How do you do that box selection thing that you just did to change the eyes all at once?
Oh, it's hold on Alt and click and drag.
TJ just said that it would help if we look back at the other vids, won't it? Yes, you should have. You should have watched. Everybody that's in the class should have watched all of the videos. That's going to be something that we're going to be really picky about in the future. We're trying this out with this class right now, where people are coming in late, meaning that they registered in just the last couple of days and they've missed the first 2 classes. But if it becomes a problem to where those people are simply going to not go back and watch previous videos, we will end up cutting off registration and not let people into classes that have already started. We will be rerunning, like the 101 class will rerun again at a point in the future. But it's really important for those of you that have come in late, please make sure to catch up on the other classes.
Dave Stewart asked a question, and I just added it into the homework. He said, so it's only showing the last guess when displayed? No. After every guess, the screen will get cleared, and the entire history of your guesses will be formatted, will be displayed.
You could go ahead and show it with those 3 guesses now.
Can I go ahead and what?
You could go ahead and show it with those 3 guesses now. Just move them.
Yeah.
We'll put some more in there too.
Nelson has a hard time coming up with the... There you go.
No, that's not right. So something like... So something like this would be the result of 1, 2, 3, 4, 5, 6, 7 guesses. Is this ran like srand in C++? Srand is used to seed the random number generator. In the case of C#, random is actually a class that has its own seed, and by default, it'll generate its own seed, a time-dependent default seed value. Alternatively, you can specify your own seed. And then random.next will perform just like the C+ or the C method rand. Not method, function. All right, well, is everybody good with the... How many chances do you get before you lose? I would say right now just infinite. If you wanted to throw in a reasonable cap, then that would be good too. Again, reasonable. And if you do throw in a cap, present to the user how many guesses they have left.
And
if you want to do extra difficulty levels, you're more than welcome to. Well, it depends. That's actually a question for Gavin.
I'd rather see
just
this
a uniform
coming in.
Homework submission.
It makes it, yeah, it's very difficult to just balance it otherwise, because we've got people with vastly differing skill levels and backgrounds and approaches to. I did find that with the first homework, the Thursday set were a lot easier to mark just because I made it clear that it was simpler was better.
All right, so this puts us right up to 2 hours and 55 minutes recorded. So we're getting better. But
yeah, 2x summed it up. You could do all that, but submit the one they ask. So yeah, we're not stopping you making the best Mastermind game ever produced for Windows 7. But that's not the one that I want to see.
And Barry asks a good question, and that is, when will the homework outline be posted? I guess as soon as we wrap this up, I'll begin encoding this video so we can get it up soon, and Nelson can...
Yeah, I'll just have to give me 5 minutes to format it up, and I'll put it up on the thread.
Sounds perfect. And then we can update the calendar system as well so that it has a link pointing to this homework. Woot. And then deadline?
Are we doing is Wednesday the set day for these?
There is no set day. We have to kind of play it by ear, but if you want to go ahead and schedule next Wednesday, that's fine.
Yeah, it should be. I did.
Yeah,
It's the only reason being that then we can talk about the homework in that video. So we'll aim for Wednesday.
And TJ just asked if we join the class late, we should submit the previous homework, right? Yes, if you're wanting to get the certificate, you'll need to attend 50%. And all this is explained in the very first video. You'll need to attend 50% of the classes, and you'll need to submit and pass all the homeworks. So, yes. And I would like to throw out a huge thank you for you guys today. We had a really good attendance. Ended up turning up with about 60 people for the most part in the class today, which was awesome. And we had some fantastic interaction. TJ, especially, you get the award today. Really good job of asking lots of questions, and we do love it when you guys interact and ask a lot of questions. It's greatly appreciated, and it really makes it feel like, you know, this approach to training is so much better than just a static video, because we love interacting with people, which is really good stuff.
Any mention about C++ class?
Yeah, that's one of the things you and I are going to talk about this evening and see if we can go ahead and get a date and all that good stuff all wrapped up. It's ridiculous how many people are asking about that. But that's good. I mean, we'll teach it.
Yeah. But Wendy, this homework is a toughie. If you pull this off, you just have a pretty good sense of, accomplishment. This was one of the first programs that I remember writing when I started out.
And we will be making
and always remember to break it down into steps if you get stuck, because you can just end up staring at a blank screen going, right, make a game. Where's the make a game button? Just break it down into the steps, one thing at a time, and make sure that works, and then move forward. Yep. Otherwise it's easy to get discouraged.
Yeah, don't let that happen. Plus, remember, we will be making ourselves available this coming Wednesday evening. It'll be at 8 p.m. Central Standard Time. So that is like 1 o'clock in the morning, unfortunately, where you're at, Wendy. But yes, we will be making ourselves available, and you guys can come in and ask questions as well. Even though we won't outright say, here's how to do the homework, we can still answer questions in regards to, concepts that are related to what it is you are doing. So yeah, awesome class. A lot of interactivity and a lot of attendance today, all the way up to the end. That's fantastic stuff. So let's go ahead and wrap this up, so that we can start getting things encoded and the thread posted for you guys. You guys all have a wonderful day. Again, thank you very much for joining us. It's been a fantastic Monday. And we will see you around 3D Buzz. Bye, everyone.
See you.
Bye.